Hello everyone and welcome to Vidyarthi Point. Today our topic is problems on train. So in this chapter we will solve the problems related to train using the concept of speed, distance and time. So before solving these problems you should have a clear concept of speed, distance and time. Now speed equals to distance by time. Using this formula we will be solving all the problems related to trains. But here are some exceptions. Let us look at the exceptions here. Here two objects are used. Object 1, object 2. This is the object that crosses another object. Object 1 will be the object which will be crossing another object. Here the example will be train, bus, car, etc. Now object 2. Any object which the object 1 will cross will known as object 2. That is, 1 is travelling from this point to this point. If object 1 crosses any object at this point, then this object will be known as object 2. Example of object 2 may be a pole, a man, a platform, or even another train. Now let us look at the concept of distance. In distance, in the formula S equals to d by t, that is speed equals to distance by time. Here in distance, length of the train will be added, that is length of the second object will be added. It may be any length, it may be in kilometer, meter, etc. Now if a train crosses any vertical object, which will be pole, man, tree, then in this case length will not be added. Why? Because in this case the length will be 0. But if the train crosses horizontal object, that is platform or another train, then the length of the platform or another train which the first train will cross will be added. That is, here object 1 if crosses pole, then the length of object 2 will not be added. But if the object 2 is platform or another train, then here the length will be added to the distance. Now let us look at time. Like the speed is changed according to the direction of the object, or if the object is stationary or moving, and the distance is also changed according to what the first object crosses, time is not changed. Time is always constant. That is, if in the question the time is given as the, for example, 50 kilometer per hour, then this time will be taken in the formula, that is S equals to d by t. The time is always constant, that is the time will be given in the question. We neither need to add any extra time or subtract it. Now let us look at some important points. Number 1 is, when a moving train crosses a standing person, that means here object 1 is moving whereas object 2 is stationary. So here the speed of object 1 will be taken. Why? Because object 2 is stationary and its speed will be 0. So this is the fundamental formula, but in this case it will have a slight change, that is speed 1, since speed 2 is 0 equals to length 1 by time. This length 1 is the length of the train. Here object 1 is a moving train. When a moving train crosses a standing person, here moving train is object 1, whereas standing person is object 2. So in place of distance we have to take the length of the train. So when a moving train crosses a standing person, S1 equals to L1 by time. T is the formula. As I have said, T is always constant, but here L2 is not present because this is a standing person. So L1 is taken also. S2 is 0 because the object is stationary, so speed 1 is taken. Now let us look at point number 2. When a moving train crosses a moving person in the same direction, here the direction is given, so we have to think of the relative speed. Here same direction is given, so whenever the direction is same, the speed is S1 minus S2. Now let us see if the object is stationary or not. S1, that is a moving train, that means S1, this is the object 1, moving train is the object 1, crosses a moving person is the object 2. Here the object is not stationary, but it is a vertical object, and I have explained earlier that whenever the object is vertical we do not take its length. So here this fundamental formula will be changed into S1 minus S2, because here we are taking the relative speed in the same direction, which is S1 minus S2 equals to, in place of D, L1, which is the length of the moving train, because the length of the second object cannot be taken since it is vertical, so only L1 is taken, and as usual the time is constant. So this is the formula when a moving train crosses a moving person in the same direction. Now let us look at point number 3. When a moving train crosses a moving person in the opposite direction, again here speed is S1 plus S2. If it is in the same direction, then the speed was S1 minus S2, but in the opposite direction it is S1 plus S2 equals to. Now let us look at length 1 and length 2, that is length of object 1 and length of object 2. Object 1 as usual is the moving train, and since it is a train, L1 is taken. Now let us look at L2, crosses a moving person. Again the second object, that is the moving person, is a vertical object, so L2 will not be taken, divided by time as usual constant. So now this is the formula whenever a moving train crosses a moving person in the opposite direction. Now let us look at point number 4, which is when a moving train crosses a platform. Here the direction is not given, so speed of object 1 will be taken. Here the speed will be S1, since it is a platform, that is the object 2 is a platform. Moving train object 1, platform object 2. Here object 2 is stationary, so S2 is again 0. Now moving train length 1, that is length of object 1. object to platform. Platform will also have a length. Why? Because this is a horizontal object and not vertical. So the length of platform will be L2. So L1 plus L2 divided by T. And this is the formula whenever a moving train will cross a platform. Now let us look at point number 5. When a moving train crosses another stationary train. Here object 1 is moving, so its speed is s1, and object 2 is also a train, but it is not moving, it is stationary. So its speed, that is s2, will be 0. Similarly, like a platform. Now s1, the speed will be equal to length of the moving train. Now the length of the second object will also be taken. Why? Because this is a horizontal object. Although it is not moving, it is stationary, but it is a horizontal object. So length of the second train, though stationary, will be taken divided by time, which is always constant. Now let us look at point number 6, which is when a moving train crosses another moving train. So here both the objects are moving. Now since both the objects are moving, here we have to take both the speeds s1 and s2. Now if they are moving in the same direction, that is the moving train is going in this direction and the second train is in this direction. If it crosses in the same direction, then s1 minus s2, same direction, equals to, now length of the object 1, L1. Now since the second object is also moving, we have to take its length, that is L2 by T. This is the formula in case of same direction. Now if it is opposite direction, both the speeds we have to take, that is, this is the second train, that is the second object, and this train is going in this direction, this train is coming in this direction, that is in opposite direction. In such cases, S1 plus S2 equals to L1 length of first train plus L2 divided by the time, which is always constant. So this is the formula in case of two moving trains in same direction and in opposite direction. Now let us look at point number 7. When a moving train crosses a person sitting in another train. Here there are three objects. The moving train is obviously the object 1. Now person is also an object, another train is also an object. Here the person is vertical object, train is horizontal object. Here object 1 is moving and crossing object 2. The object 2 that it is talking about is the person which is sitting on a horizontal object. But here the object 2's length will not be taken. Why? Because although object 2 is sitting on a horizontal object, but the train is crossing this object which is vertical. So this is length 1, this is length 2 will be 0. Because here we are talking about a person and its length is 0. So if they are moving in the same direction, that is, if the object 1 is also moving in this direction and object 2 is also moving in this direction, same direction, here S1 minus S2 is L1 by time. L1 is the length of the moving train and time being constant. Now if they are moving in opposite direction, that is either this way, that is towards them, or both are going in another direction, then opposite direction is S1 plus S2 equals to L1 by time. So this is the formula for this. And with this is a wrap to the concept of problems of train. Using the important points and the formulas, we will be solving the questions in our next video. Thank you.